So this is the first problem of today's contest, Codeforces Educational Round 158. The problem says that there is a route which can be represented as a number line, and you're located at the point 0 in the number line, and you want to travel from the point 0 to the point x and return back to the point 0. You travel by car, which spends 1 liter of gasoline per 1 unit of distance. And we would start from the point 0, like when we start, the gas would be full. And there are some gas stations at the points A1, A2 till AN. And at these gas stations, we can just refuel the car. And we have to tell what is the minimum possible volume of the gas tank in the car, which would allow us to uh, complete our journey from point 0 to point x and then back to point 0. So what the problem says is nothing but that there is a number line from 0 to x. There would be some gas stations in the middle, A1, A2, AN, and so on. At the beginning, we would be in a car. Okay, my car is not looking good, but there would be a good car. We would start from here and move on till x and then come back. In the way, initially we have the gas tank to be full, like we are having complete fuel. As we move, the fuel will go down, and at the gas stations we can just refuel it till the complete capacity, obviously. Obviously till the complete capacity. I think that they have not mentioned it explicitly, but um, it's kind of obvious. So we have to tell what is the minimum volume of the gas tank which we need for completing the journey. So is the problem clear? Please say yes or no in the chat. Okay, fine. So for this, one thing which should be very obvious right now is, let's say if the distance between 0 and A1, if it is like this is the distance is nothing but A1 right now. If the capacity of the gas tank is less than this, the car can't travel, right? The car cannot travel in that case. Similarly, for the distance between A1 and A2, the distance between A2 and A3, and so on till the distance between A of n minus 1 and A of n, right? The capacity should at least be greater than equal to the absolute difference of any two consecutive elements. This is something I can very easily say. Yes or no? After that, you see that you have to travel from 0 to A1. After that, you would just have to travel to consecutive gas stations. This is nothing but the maximum, like the absolute difference of the elements. And this is from 0 to A1. After that, you would have to go to X and come back. So this region would be covered twice. Can I say that the answer would be nothing but the maximum of this, and the twice of this? Whatever the maximum is, I must have at least that much capacity, and there is no point of having more capacity. Like this would be the minimum capacity you do require. So we can simply say that the answer is the maximum of A1 minus A0, like A1, like nothing, just simply maximum of A1, A2 minus A1, A3 minus A2, and so on till A of n minus A of n minus 1, and then twice of, like, just take the twice of the last distance, this distance, which would be 2 into x minus A of n. Just find out this thing, and this would be our answer. So is that clear? Does this make sense? In the code, we have done that only. First of all, took the inputs, then just calculated the maximum of the absolute difference for every AI from the last time we filled the gas completely, like just doing that very same thing in this way, and then took the case for an to x and then back from an x to an like this, and just printed the maximum of it like this. Okay, that's great. So let's move on to the next problem in that. Okay, so in the second problem, what it says is there is a ribbon divided into n cells numbered from 1 to n from left to right. Initially, an integer 0 is written on each cell. Monocar plays a game with the chip. The game consists of several turns. During the first turn, Monocar places the chip in the first cell of the ribbon, and during each turn, except the first turn, Monocarp does exactly one of the following things. Move the chip to the next cell, or just choose any cell and place the chip on that place. And whenever you, like after the end of every turn, the integer written in the cell will just be incremented by 1. And what we want to do is make an array which is being given to us. Like we would be given an array and we want to form that kind of array. So it's like you can imagine it like this, that there are some spaces, there are some places, and you can just place up the chip at any place. Starting from this, you might take it on the right, take it on the right, and so on. Or maybe you can just put it again at some place by teleporting it. Wherever you teleport it, just increment the counter again. You want to form the array C1, C2, C3, Cn. You want to form this array, and you want to have minimum number of teleportation operation. The operation which involves teleportation, you want to have that minimum number of times. So is the problem clear? And after finding it out, what we have to do is just print that counter, print that minimum counter. So is the problem clear? Yes, no, something? Okay, fine. Now let's look at the obvious things, or maybe we can just look at the intuitions. If I'm having some array A1, A2, A3, let's say, and this A1 is less than C1, in that case, I do definitely want my ribbon to be at this place, right? I do want it to be at this place. And the only way I can reach to the first place is by teleportation. So this is obvious that after the, except the first turn, again and again, I would have to take the ribbon at this place. Like I would have to take my ribbon to the first cell C1 number of times, right? C1 number of times. Whenever I come to this place, going to the next uh, cell is not really causing me any teleportation operation, right? It's not actually incrementing my answer. I want to find the minimum cost and it's not incrementing my cost. So if the next cell A2 is less than C2, I would definitely go to the next cell. Only in the case when A2 is equal to C2, I want to go there, right? Is this point, does this point make sense? That if I'm at any place, let's say AI, I'm coming at this place, maybe let's talk about any index I, and I have to come here at CI number of times. So on those CI number of times, I would always consider going to the next cell, unless and until I have already reached to that cell the number of times I wanted to reach there. Every time I would go to the next cell. So for any index AI, like the array C is given to us. So for any index where Ci is less than C of I minus 1, do I really need to apply any teleportation operation for the index I? Just try to think about it. If the array was something like 5, 4, 3, 2, 1. if I come to this cell by teleportation, do I ever need to apply teleportation operation for this cell? So the answer is obvious, like I never need to apply it. Whenever I come to this cell, whenever I place the ribbon, whenever I place the chip on this ribbon or cell, I would always, after this, just take it to the right step. After that, again, I would take it to the right step. I would just always do this until and like until this value has become 4, right? Initially, all the values were zeros. It got 1. So I would definitely go to the next cell. I would definitely go to the next cell until I reach a 0. Then after that, I would just come back to the first cell and let's say place it like this. Again, since the next value is less than the value I wanted there, I would just go there again, right? And I would stop it in the case where you are actually having some matching values like this, these two, where you have got the match, right? Does this make sense, this part? Okay, great. So one thing from this you could notice is that the array C you have, the array C which is being given to us, if there is any element Ci which is smaller than the previous element, you never need to come to this place using a teleportation operation. You would always teleport to C of I minus 1, or maybe even some or maybe some other cell which is even less than I minus 1, and just come to Ci by using a right operation. The only time when you would have to apply some operation is gonna be when like Ci is greater than C of I minus 1. Even if it's equal, you don't need to apply any operation. But in case when the element is greater than the last element, you do need to apply some operations, right? If it is something like maybe 5, 4, 3, 2, 7, in that case, what you could have done was take the ribbon here, then here, then here, then here, then teleport it back to this place, then go ahead like this, then again teleport it like this. So you would be going there, you would be going there. But after this point, you can't really go there. So if you can come to the previous cell only 2 times, then you would be coming to this cell by using the right operation only 2 number of times. So for all the other operations, so for all the 7 minus 2 number of operations, you would have to apply a teleportation here, right? You would have to apply a teleportation here. Yes or no? Yeah. So this is the main idea. This is the main idea and the problem, that for any index I, if it is smaller than the previous element, you don't need to apply any teleportation here. But if it is greater than the previous element, um, any element Ci, if it is greater than the previous element, then this many times you would have come here by using the right operation. For the remaining C of I, like Ci minus 1, this many times you would have to apply the operation here. So you can just increment it to a variable answer and then output answer at the end. That's it. Okay, so shall we look at the code, or do you have any doubts? If you have any doubts, then please ask it in the chat. And yeah, you can look at the test cases here. Okay, okay, great. So in my implementation, what I did was to just first of all take the inputs. What if there is a 0 in the array? Okay. So someone is having a doubt that what if there is a 0 in the array? Let's take the case 1 0 1 0 1. Now in this case, according to what we have decided, for the first element, you would have to come here only 1 number of times. And for the next element, you don't need to come at this place. So like you don't care about anything, right? Uh, what we would do here is that um, you don't need to come here because it is already smaller than the previous element, right? This is coming up in, uh, where is that case? We wrote this case. Like, yeah, if it is smaller than or equal to the previous element, so you never need to come here. And you would just skip it in that case. Then you talk about this element, you would just increment the counter again. Initially, your answer is 0. You come to this place, you increment the answer by 1. You come to this place, since it is already smaller than the previous element, you don't do anything. Then you come to this index, it is greater than the last element by 1 amount. So you increment the answer by 1. Then again, 0 is smaller than the previous element. Then 1 is greater by 1. So you would just increment the counter again. And sorry, a counter would be incremented to 3. And you see that for the first case, you didn't really require to use the teleportation. You were already coming there. So you would just print the answer -1, right? Like this. This is how I did implement, declared a variable answer. And for the last index, like you don't really need to create a variable for that. You can just use a of I minus 1 and handle the case of I equal to 0. So I'm just going to every index, checking if it is greater than the last element. If it is greater than the last element, then increment ai minus last to the answer. Otherwise, last is equal to answer. Oh, sorry. Uh, Not otherwise, but in every case, just updating the value of last. And then at the end, printing out answer -1. Here I'm subtracting 1 because for the first operation, you don't really need to apply the, like for the first one, you don't really need to apply the teleportation operation. It would directly start at 1. So is it clear or is there any doubt? It was a greedy solution. It was a greedy problem. So is this clear or not? Okay, clear. That's good. Let's see the third problem then. In the third problem, we have been given an array A1, A2, A3, An, where all the elements are in the range from 0 to 10 raised to the power 9. In one operation, what we can do is just choose any index or any integer x in the range from 0 to 10 raised to the power 18 and replace ai by ai plus x floor division by 2. And we have to do this for all the indices in every operation. We have to find the smallest number of operations required to make all the elements of the array equal. And in case if the number of operations we need to do is less than equal to n, then we have to print all the x which we chose for making all the elements equal. Is the problem clear? Is the problem clear? We are being given an array, and in one operation we can just choose some x and replace the array by a1 plus x by 2, a2 plus x by 2, and so on till a of n plus x by 2 by this. And what we aim to do is make all the elements equal. So one thing you can notice here is, let's say if if there is any number mn and any number mx, and you apply some series of operations on them by choosing some different values of x. Let's say from the value mn, it becomes equal to y. And there is some other number with name mx, and it is also becoming y with that same operation, with that same series of operations. So all the elements in this range from mn to mx would also become equal to y. This is something which looks obvious. Just for the purpose of giving you some logical proof, you can think of it as every time whenever we are applying the operations. Right now, when I say operations, I'm talking about this operation which we discussed in the problem. So whenever we apply that operation, if instead of some ai plus x by 2, if it is giving some value, any aj where aj is greater than ai, this thing would definitely be either greater than or equal to that. I hope that this thing makes complete sense. If you choose any value for aj which is greater than ai, then after applying the operation, the result would definitely be greater than or equal to that value. Yes or no? Does this thing make sense or not? Um, okay, maybe let's take one example as well. So if I say that I'm applying an operation on 7 and I add 1 here, 7 plus 1 by 2, which becomes 4. So if I choose any number which is greater than 7, let's say I choose 9, after applying the operation, the result would definitely be greater than or equal to that. है ना? So if there is any range from mn to mx, mn and mx are both giving the same output after some operations, all the numbers in the range would definitely give the same output. It can, like, this is the proof with sandwich theorem. And I think it looks obvious as well. So what we could notice here is that for the array, for all the elements which I want to make equal in the array, I don't really need to choose, find all, like compare all the elements. I can just take the minimum value of the array, maximum value of the array, and apply some series of operations to make them equal. If maximum and minimum are becoming equal at the end, all the elements in the array would have also got the same value, right? Yes or no? So right now I'm going to denote the minimum value with mn and the maximum value with mx. Now you can notice one thing. When I have mn and mx, let's say I add x to both of them and divide them by 2, whatever difference they had initially in mn and mx, whatever difference they have right now, mn plus x and mx plus x would also have the same difference. There would be no difference in the like there would be no change in the difference. And when I divide them by 2, when I do divide them by 2, right now I'm talking about complete division, not just uh, I'm not talking about the seal or flow division, I'm just talking about division. So whatever the difference initially was, it would just get divided by 2, right? It would just get half. Yes or no? Okay. So when I talk about this mn plus x by 2 floor and mx plus x by 2 floor, in this case, what will happen is the difference would either become the floor or the seal. It can become any of them. But does this really depend upon the value of x? This is the question here. Here, this thing you can notice that it doesn't really matter what the value of x you chose. What matters here is this part even or odd? Is this part even or odd? It would just matter on this thing. Whether the numbers which are about to be divided are even or odd, on that base, on that thing, it would depend whether the new difference you will have between the two elements would be floor divisible, like divided, like division by diff by 2 floor or diff by 2 C. Right. Let's take an example. If you have a number as 2 and 4, now it doesn't matter whatever value of x you take here. At the end of the day, the difference among between them would become just equal to 1. Right now the difference is 2. After that, um, the numbers will become like this, and the difference would be just 1. And now, after that, after one more operation, the difference would again just keep getting halved again and again. So what matters here is whether the result is even or odd. So in the case when the Mn and Mx, let's take Mn and Mx, if both of them are even, it doesn't matter whatever value of x you take, whether it is even or odd, because the difference would be just 1. If you see on the LHS and RHS, the only difference would be in the halved value of these elements, and x by 2 would be just the same thing. So the difference would not really matter much on x. है ना? Whatever the new difference is doesn't depend upon x. If both numbers are odd, again the new difference doesn't depend upon x. But what if one number is even, one is odd, or if one of them is odd and another one is even, like in these cases doesn't matter on x, does not depend on x. But in these cases it does depend. Please tell me one thing, whether this part is clear or not, about this part, that why does it not depend upon x? Okay, great. When it does depend upon x, what will happen in this case? Let's take an example for this. What if Mn is 2, the minimum value in the array is 2, and the maximum one is 9? So in this case, the difference right now is 7. And after, let's take x equal to 0 for now. After division, it would become 1 and 4. So the difference is now 3. It is less than the half of 7. है ना? In this way, we have got the difference reduced more than half. है ना? And this is what we desire. We desire this thing. The minimum element should be even and the maximum element should be odd. In that case, the difference is reducing faster. At the end, we want the difference to just become equal to 0. And let's take an example for this case where the minimum element is odd, let's say is 3, and the maximum element is even, let's say 10. Right now the difference is 7, and after division the elements become 1 and 5, where the difference is 4. So this case is not desirable, right? In these cases, we don't care. We can just pick up x equal to 0. Like it doesn't matter what we pick. And in the other two cases, um, we want this case to happen, and this does should not happen, right? Is this what we want? Yes or no? Is this what we want? Yes. So can we do something here? Can we do something when Mn is odd, when the minimum element is odd and the maximum element is even? Can we do something? Can we do something? One thing we can do is just pick up x equal to 1, because before dividing we are adding x. So Mn plus 1 would become even and mx plus 1 would become odd, and after dividing them they would just the difference would actually get reduced. Let's take this example. When 3 plus 1 and 10 plus 1, 3 plus 1 is 4 and 10 plus 1 is 11. After dividing them, 2 and 5, and the difference is now 3. So we have reduced the difference in this way. So what we can do here is just pick up x equal to 0 for these three cases where you like everything is good or you can't do anything. And in the case which you don't desire, where the minimum element is odd and the maximum one is even, just add 1. Let's take x equal to 1 for that case. And would anyone like to guess what would be the maximum number of operations you would have in any of the test cases? Maximum number of operations in any case. Anyone having any idea? Um, the maximum number of operations would be nothing but log 2n, because we are just dividing the numbers, both all the numbers, by 2 again and again every time, right? Whatever number we have, we are just dividing it by 2 again and again. So let's say maximum of 33 operations, or maybe not even 33, 31, 32. In after these many operations, it would just become zero. All the numbers would become zero. If you just choose x equal to 0 for all the elements, it would become, all the elements would become zero, and the array would have all the elements equal. So you never require more than 33 operations. So what I can say is that at max, I would have this complexity. If I'm just comparing the minimum and maximum again and again, at max 33 into n number of times. Yeah. Okay. So now we can just let's just look at what we can form as the approach. Take the array as input. Take array. Find min max, min and max of the array. After finding the minimum and maximum element of the array, you just want to make them equal. So you will say that, hey, in case if min is odd and max is even, like until they are equal. So you will have while min is not equal to max. If min is odd and max is even, then x equal to 1. Otherwise, x equal to 0, and apply the operation. Just keep doing this. We have seen that for any values of mx and mn, you will have maximum of 33 operations, not even 33 operations. And um, at the end of the day, you can say that in every test case, since you are having 33 operations and the maximum number of test cases is 1e4, the time complexity is just simply 33 into 1e4, right? You don't even care about n, like this is for the part of dividing, and for taking the inputs, the time complexity is just big of n for taking all the inputs. So this is the overall time complexity. Let's see the code. So the way I did code it is, first of all took the inputs, then found the like minimum and the maximum value of the array, created an answer array in which I would just keep track of all the values of x I'm choosing. While mn and mx are not equal, I would just first of all find the value of x I have to take. In case if the minimum value is odd and the maximum value is even, in that case x would become 1. Otherwise, one of the conditions will fail and it would return false, which would become 0. So in that case it would become 0. Okay, I would take the case of 0, 32. Yeah, after finding the value of x, we would just push it into the answer and apply the operation on mn and mx. After that, we will just print the size of answer, like this is the number of times we applied the operation. And in case if we are having the answer size as less than equal to n and it is not 0, we would print the array, the elements of the array. So is the code clear? Like, does the code make sense, that why are we doing it in this way and how does it work? Okay, great. So let's take the example where minimum element is 0 and the maximum element is 32. Since it is like uh, even and even, like this is not the case where you have odd and even. So we will just take x equal to 0. They will become 0, 16. Again x equal to 0, 0, 8. Again x equal to 0, so 0, 4. Again x equal to 0, 0, 2. X equal to 0, 0, 1. And x equal to 0 again to make it 0, 0. So we did require six number of operations here. We did require six number of operations, and the output is also six. Um, no, what I said was like log2 here is approximate. This is approximate. This is approximate for the correct value. Like that's why here, if you see, the log of 29 would be somewhere around 30, 29, 30, whatever you say. But I said 33 because I was just taking one, two extra elements, extra size. So if you like wanna find the accurate term, it would be something like log 2 n plus 1 or log 2 n plus 2, something like that. So is your doubt clear? Okay, great. So let's move on to the next problem then. This is the D problem. In the problem, we have been told that Vasya is a sorcerer that fight monsters. Again, there are n monsters standing in a row. The amount of health points for the ith monster is AI. Vasya is very powerful sorcerer, sorcerer, who knows many powerful spells. In this fight, he decided to use a chain lightning spell to defeat all the monsters. Let's see how this spell works. So firstly, Vasya chooses an index, like it's boring. Let me tell you how does it work. So what happens is that you are having many monsters, A1, A2, A3, AN. These the array is representing their health points. What you can do is just choose an index, like the count, like the index of the monster on which you would use a spell, and the, let's say, attack power, the power of that attack. Let me just call it as power for now. So let's say you chose the index 3. You chose this element. You chose this monster. Let me draw it here. The monsters were A1, A2, A3, A4, A5. Let's say you chose this index and the power to be 8. Now what will happen is this monster will get a damage of 8. So in case if A3 was less than equal to 8, this monster will die. Otherwise, this monster won't die. है ना? And what we want is we want to kill all the monsters in one go. We want to kill all monsters in one go. Kill all monsters in like one spell only. So if you use the spell on this monster with a power of 8, it will cause a damage of 8 on this monster, and then um, any other monster which has not been hit yet but is adjacent to a monster which has already been hit, like this one or this one, which are not hit but they are having a neighbor which has been hit. On any one of them randomly, the one to be hit next would be chosen randomly, and any one of them would be chosen to be hit, and they would get damage. Like the damage they would get is gonna be equal to power minus 1. This one got the damage of power. This one will get a damage of power minus 2, and now this guy or this guy, any one of these two guys, would get the next hit. Let's say this monster got the next hit. So the damage would be power minus 2. Then maybe this monster, since it is the only choice now, power minus 3 would be the damage. And then power minus 4 would be the damage until all the monsters are hit. At the end, when all the monsters are hit, that's it. Now, all the monsters who got damaged more than their health points would die. And we want to kill all the monsters. So that's what this problem says here. So is the problem clear? Okay, great. Now, what we can try to see here is whatever power you had, you got some reduction in it. You know, you got some reduction in it for hitting some monster. Let's say I chose index. Let's say I chose some index, and the damage on the monster on, let's say, 8th index would be the power with which I did hit, and some reduction which is going to be equal to the number of monsters which have already been hit before this monster. This would be the damage. It should be greater than equal to A8. Only then it can kill the monster. Right. Here we want to find out the minimum possible power. Minimum possible value of power with which when you chose some index and some like some index and this minimum possible value of power which can kill all the monsters for sure. So this thing should definitely hold. The power minus whatever the reduction was there should be greater than 8. Let's say if there was any index I, then it should be greater than AI. So can I say that I just want to find out some possible value of power for like if I find it for every index. Maybe let's take it in this case. There is power and index. You don't know about any of these right now. Right now you don't know the value of power or you don't know about the value of index. है ना? So what if we consider every index? Like this is a way in which I always think if the problem doesn't directly strike, doesn't directly look very obvious, then I just try to simplify it. So what if I try to think that I know the starting point? Let's say if I have decided that I would be starting from the index 0, or what if I decide to start from any index, let's say 5. Let's say that I would start from the index 5. What would be the power I require? If I can find this, then I can just do this for every index, and whatever is the minimum power I required somewhere, I would just say that this is my answer. And does this thing make sense? Does this thing make sense? That we are just fixing indices, and for every index we are finding the minimum power, and then we are seeing that um, this minimum power is our answer. So the steps are like fix all indices from 1 to n, one by one, and for all the indices find the minimum required power. Now this part of finding the minimum required power for a fixed index is doable. It is very easily doable because what you need is, if you know that you are going to choose this index, as you already know about the index, all the other values, you can just say that, hey, what will be the minimum possible damage I inflict on this monster? Let's say if this is index I and this is index j, and I want to find out the minimum possible damage I would definitely hit at the monster j. It would be the power minus the number of elements in this range, right? If I have already damaged all the elements in this range, this is the maximum my damage could have got reduced. So let's say if there are n minus j minus 1 number of elements at this place, then power minus n minus j minus 1. This would be the damage at this monster. I want it to be just greater than equal to aj, right? Yes or no? Which means that I want power to be greater than equal to aj plus n minus j plus 1. right? And that's true for all the elements on the left side. Now, when you talk about all the elements on the right side, instead of covering the talking about the elements on the right side, you would just talk about all the elements on the left side. So you would just say that if your k element, let's say an index k is happening here, you would just say that power should be greater than equal to ak plus k yk, because these are nothing but k number of elements if you have zero based index. है ना? So in this way, you can just find out the power required for any element if you already know about the starting index, if you have fixed the starting index. But what if you don't know about the starting index? Like right now, the time complexity here is big of n for finding all the starting index, like when you are fixing all the starting indices, and big of another order of n for finding out the cost for every index. Um, I think binary search wouldn't work here. Like, how will you use binary search here? I don't know about binary search, but there is some better way. There is some better way. You can just see that for this element, what you cared about, yeah, prefix suffix. For this element, you just cared about um, for any index I and j, the um, this, like, sorry, not power, but aj. One thing is aj and the absolute difference I and of I and j. है ना? This is the thing to maybe like not even like that. Maybe we can simplify it. Uh, Maybe it can be simplified, but if I talk about the way I did, first of all, I just calculated all the prefix max in a way that for any index, index like this, um, let's say this is I would know about the maximum cost for any element if it is aj plus this absolute difference, this absolute of I plus j, I minus j, the maximum of all the indices smaller than this in this way. Yeah, I think that it might be looking a little bit complicated. Uh, the key idea here was that I didn't really need to find out the maximum on the left and right again and again. But if I just try to pre-compute it, what if I just try to pre-compute all that? For that, I could have used a prefix sum array and the suffix sum array. So just imagine if I have the privilege that for every element, I just know that at like what is the uh, minimum power I require on the left side if I just directly go on the left. If I don't go on the right, I just directly go on the left side. So what is the minimum power I still require? This is AJ. If I just store this thing, that if I start from this place, what would be the minimum power I require if I just go on the left side? And similarly, I can just store for the right side. And if I know about this part of finding out, if I know about this part of finding out the max, like the minimum power I require, the minimum power I require to kill all monsters on the left, then I can just say that I would require this much more energy, because in the worst case, what will happen is I would, or maybe this much more energy. What will happen is I would first of all fire at this place, then here, then like I would just hit all the monsters on the right side and then come on the left. So if I know about the cost of the minimum possible power I require for killing out all the monsters on the left, I can just add up this part to find the total cost. Okay, so please tell me how much did you understand? I think it would be a little complicated in the way I have explained. I tried to tell about the intuitions I got, but it doesn't look very intuitive right now for the purpose of explaining. Can you please explain it once again, the last part? Yeah, yeah, doing it. So what we did initially was that for every index, we were just finding out the cost again and again, right? For any index, let's say this is the index I was just finding out the cost I require to kill all the monsters on the left and for the right. है ना? That's what I required. I just said that if I'm at index I just want to find out uh, the maximum of aj plus absolute of I minus j for all for all j less than I, or maybe even equal to I. That's what I wanted to know. Let's talk about less than I right now. Yeah, for this part. I just wanted to know about this. Are you with me till now? For every index, let's say I have fixed the index right now. Then I just want to find out what is the maximum uh, of the damage I need to inflict on a monster on the left side. Once I find it out, I will just add the count of these elements. I will just add the count of these elements. I can say it in this way also. One way was to just find for every element, just check that aj and add this part. Or the other thing is, I just find out the maximum of aj plus this part for every element and then at the end add this part. I know this is the same thing. Instead of picking up this and adding this for every index, I'm saying that find out um, this and this, like the sum of these two as the maximum, and then at the end we will just add this, and we can actually pre-compute this part. This is a standard thing. This is a standard thing where we just do something like this. Find the absolute of I minus j and aj, the sum of them. It's like you want to find out. It's like as far the element is, the cost is increasing, and you want to find the maximum cost. It's like that. I expect that if you're solving the D problem, then this is something you already know about. This way of pre-computing the things. And once we are done with it, once you have pre-computed it, then for every index, you know about the cost on the left side in the pre-array and the cost on the right side in the sub-array. So it's now very easy for you to find out the total cost, because for any element, any index I, you can just say that um, the cost on the left would be pre-I plus taking out all these elements. So this is nothing but n minus I. This would be the cost when you are talking about the maximum cost, the maximum, uh, yeah, the maximum power you require for any of the monsters on the left. This is the maximum. Like if you have this much power, then you would definitely kill all of them on the left. And for the monsters on the right, it would be in sub I plus I plus 1, right? And the only other monster is the monster on the ith position, it would be AI. Just take the maximum of these three things, and that's the answer. Like that's the answer for this index if you choose this index. And you can just run up a for loop for every index, and whatever you get as the minimum of like the max, first of all take the maximum of these three. It will give you the cost I, let's say. Then just take the minimum of all the cost, and that would be the answer. This would be the answer. So yeah, the problem got a little complicated at the part of pre-computation. Otherwise the problem is just simple. This was the only difficult thing in the problem. So is it clear, or do you have any doubts? Like if you have any doubts, please ask me in the chat. Okay, clear. Great. Then let's see what we can do now, how we can do this part. So what we see, for every element, for every index, you just want to find out um, the element having the maximum aj plus absolute difference. Element having, like the element in which aj plus absolute difference is maximum. You just want to find this part, right, on the left side. So what you can do is, as we do in the prefix sum array, just start from the left side of the array. Keep track of the maximum value there. Keep track of the maximum a of j plus absolute of I minus j till now. Let's say you are talking about this index. If you have pre-calculated this part till this part and you want to find for this I plus 1th index, what you can say is, if I call this as mx right now, maybe uh, pre of I, then pre of I plus 1 would be nothing but the maximum of a of I plus 1 and pre I plus 1. Because whatever the maximum of all of these were till now, it would just get this thing increased. Everything else would be same. So a plus 1 for that. And like this is a sub problem. If you have not done a problem in which you do like this, then I would suggest you to try this problem first and then attempt the D problem of today's contest. Similarly, you can do for the suffix. Find the suffix. After that, for every index, you just have to do this thing. And yeah, the sub problem here is just assume that for any index I, the cost on the left side is the maximum value aj, any index aj, and the absolute difference between I plus j. You just have to pre-compute this part. This is like a sub problem. Try this out first. So let's look at the code. The first thing I did in the code was to take the inputs. After that, I declared prefix and suffix arrays. And since I had to take the minimum, uh, okay, so I declared the prefix, some like prefix max arrays for finding the maximum values, and then I just uh, did run two for loops, one from left to right and the other one from right to left. While going from left to right, I took the value, like for the first value, I just stored the value from the array and then set that p of I equal to the maximum of p of I minus 1 plus 1 and a of I. And here this initialization doesn't really create any difference. Uh, Here I should have not initialized it. Initially I was doing something else, and just ignore this part. This was a mistake made by me during the contest. but it's not affecting the answer here. And then I did the same thing for the suffix array. After that, I wanted to store a minimum value into the answer, so I initialized it with a very huge value. And for the case where we are choosing indices at the absolute left or the absolute right, in those cases, like you don't have anything on the left or anything on the right, so I just took care of them um, outside the loop. And for all the other elements which are having both elements on the left and right, I just declared an integer current in which I stored the maximum of I plus 1 of I plus 1 and n minus I pre of I minus 1 as we wrote here. This is pre of I minus 1 and sub of I plus 1. Like the way in which I have declared them. If you say pref of like pre of I just doesn't cover I, in that case it would be correct. And at the end just printed the answer. So does this make sense? Yes or no? Okay, great. So I think that we can end the session for now. And for the people who have been watching on YouTube, you can check out description to find out the codes. And thank you for watching the video.